Hello and welcome to our AnsibleFest session. Today we'll talk about high-quality Ansible collections and their impact on automation adoption. My name is Tadej and I'm an Ansible evangelist at XLAB Steampunk. Our team specializes in all things automation, primarily focusing on designing, maintaining, and certifying high-quality Ansible collections. We build collections for our own use, and we also help build product owners' Ansible collections for their products. And another thing we often, or from time to time, do is goof around in our underground parking lots. So this is where our steampunk name comes from. I'm joined today by Caleb from Sensu.
So Sensu, to introduce, Sensu is a highly scalable multi-cloud and container monitoring platform. It provides solutions for both infrastructure and application monitoring. And if you are familiar with Sensu, you may be aware of Sensu, the open source project that is the core engine of the product itself. We provide a commercially supported enterprise solution, and it's quite popular for organizations who are looking to consolidate existing tools. You may have some Sensu, you may have some old Nagios style monitoring scripts that you're using with tools like Nagios and whatnot, or applications that are instrumented with StatsD or Prometheus and looking for a way to standardize. And so Sensu provides that by means of allowing you to reuse that existing instrumentation, those plugins and integrations and whatnot, collect the data, route it through Sensu, pipeline it into the data platforms and other systems of record that your organization depends on. And we like to say about Sensu then that offers complete visibility from Kubernetes to bare metal. So to give a quick overview of exactly how that works or what that looks like, so this is the Sensu observability pipeline. This is just a very high level view, the simple concepts that enable Sensu to perform so well. And that is incoming events or observations. We will process, there's three major components to that backend pipeline. That is to filter, transform, and process those events. Our filtering engine is like a rules engine. It allows you to make decisions about when and whether to process data. And then the processing on the back end can be to store that data in a data platform, one or more data platforms, to update records in a CMDB, to create notifications or records in your incident management systems. It could go and initiate automated remediation workflows, even with things like Ansible Tower. And then in the middle, we provide what I like to call the operator's Swiss Army knife, the transform step. In Sensu, we call these mutators. This allows you to modify the payload as it flows through the Sensu pipeline and really solve a lot of those challenging problems we have when integrating legacy systems into modern tools or vice versa. Maybe we have some modern systems and some legacy product or system of record on the back end that the organization relies on. And we need to make sure that our data conforms to those systems. So moving kind of from right to left, if we understand those simple concepts of the Sensu event pipeline, the events themselves, which we process, can be service health information. They can be telemetry data, metrics from our applications and services. It can be discovery information. So when we discover a new endpoint or we discover a service running on that endpoint, that information can be processed by the Sensu pipeline and so on. And then the Sensu agent really serves a simple purpose as an event producer. So again, we can execute monitoring scripts like Nagios plugins and whatnot, capture the output, wrap it in this event context, shove it onto the pipeline, consume incoming StatsD metrics, collect metrics, scrape metrics from Prometheus endpoints. We offer hundreds of Sensu native plugins. And these are just a few examples. We can collect data from SNMP endpoints and so on. And then we wrap around that complete pipeline, all the integrations that you would expect. And that includes collecting data from any of the systems you see on the left, your cloud platforms and various instrumentation, tooling, and integrating with those systems of record on the right for that complete solution. And on top of all this, there are additional features that are provided by that event pipeline or observability pipeline in the form of scheduling, so we can manage the agents to request additional information from our systems. We provide a multi-tenant system through namespaces, so you can have multiple different organizations having self-service access to the pipeline. We have quite comprehensive role-based access controls and APIs to get access to all of it. So that's a high-level overview of Sensu. I'll turn it back over to Today to walk us through some of the technical aspects.
Thank you, Caleb, for your overview. Yeah, so I'll start with the basic unit, and that is a playbook. So when people ask me, what is a playbook? I usually describe it as a human-readable and machine-executable description of the desired state. Let me demonstrate this human-readable aspect with an example. What we are looking at now is an example from Sensu Go's documentation. And even if you never heard about Ansible before, when you read it, you get a general idea what this playbook will do. So it will install Sensu backend on one set of hosts and install Sensu Go agent and configure it on another set of hosts. But what is important to notice here is that this readability is not incidental. We actually wrote this playbook before we even started writing the code for our Sensu Go Ansible collection. We then used this playbook to guide our design and implementation process throughout the whole development experience. So this write a playbook first and then write a code approach is something that we do for each component that we add, for each new module or for each new Ansible role that we add to the collection. So another desirable trait of high-quality Ansible collections is their focus on the end result, on the state. Making modules enforce a state instead of executing an action is a great way of increasing playbook's readability. Why? Because we can remove most of the conditional logic from the playbook, making it shorter and easier to understand. If we look at the example on the slide, the name says create a check, but that is actually a lie. More accurate description of this would be if a check named check minimum does not exist, please create it, and then ensure that properties are set as in this task. If the check module were not enforcing a state, we would need to move all that logic into our playbook, making a giant mess. So yeah, another critical component of adoption speedup is familiarity. So in quite a few cases, collection users already know how to use the product they are automating. And we should do our best to let them use their existing knowledge when writing Ansible playbooks. For example, if we compare Ansible description of a check from the previous example and Sensu Go native description, they're basically the same. We just removed a few keys from the upstream description and made it a bit shorter because we were redesigning the API anyway. And this modeling the collections API after the products API is not only useful for people that are already familiar with the product, in our case, Sensu Go. It also benefits new users because they can consult the official documentation as a reference when they are writing their playbooks. But do note that familiarity is not the same as mechanically wrapping the product's API. Our Sensu Go Ansible Collections API does look familiar to Sensu Go API, but we added additional functionality that Ansible users expect, for example, check mode or change detection. But on the other hand, while familiarity is important, we should not be afraid to deviate from the API the upstream is providing. For example, we split the handler management into 3 modules. Sensu Go by itself has a different type of handlers, and we decided that because it is easier to define what properties belong to specified handler, we split those into 3 modules. We still try to maintain the familiarity, but simplified the implementation and the user usage. So user does not have to specify a type, they just pick a right handler and then they know exactly what set of parameters they need to provide to create that handler. There is another trick that we can use to make our Ansible collections easier to use and thus increase the speed of adoption of automation in our company. Because people tend to search for patterns in nature, we can improve our modules API if we make them consistent and predictable. For example, what I'm showing here is a documentation sample from, again, Sensu Go Ansible Collection. We see that all our modules have basically 2 sets of parameters. One set contains information about the Sensu backend that we are connecting to or are configuring, and the other set of arguments describes the resource we are trying to configure. Another example of this pattern, or so to say, consistency, is all of our, or most of our modules also have a state parameter, and the state parameters controls whether we want to have the resource present or absent on the Sensu Go backend. And this consistency makes it easier to write playbooks because user just needs to fill some holes in the template when writing different tasks. But another benefit of this, let's say, consistency or predictability is when something is different, it is clearly or painfully obvious that something is different. For example, Sensu Go backend does not allow us to delete users, so we replaced the absent and present states with enabled and disabled. And users are informed when they use it incorrectly that they need to update their task. And this is where I think it will be a good start to transition from talking about readability to start talking about reliability, because readability does not mean much if our end result is faulty. So yeah, Ansible collections, their primary task is to enforce a desired state in a safe and robust manner. So what we have in a playbook should be, when the playbook is done executing, present on the system that we are configuring. One way to ensure that our roles or modules do what they are expected to do is to have an integration test. If we followed our methodology of developing content, so if you write a playbook and then actually write a code to implement the functionality needed to run that playbook, we have plenty of testing material. All we need to do is run it. But the question is what to run it against. Because Ansible collections are, so to say, a link between Ansible and the product, we need to run our test on all supported combinations of versions of, for example, Sensu Go and Ansible. In our case, for example, we run our test on all supported Sensu Go versions and all supported Ansible versions. This means that users of Sensu Go collections are free to pick the supported versions of each component, and they have a guarantee that thing will still work. Another important thing in high-quality Ansible collections are also sanity and unit tests. For example, these are the tests. This is the test matrix that we use when testing Sensu Go Ansible collection. Sanity tests are basically just a check that makes sure that we follow some established practices that Ansible world has known about for ages. Unit tests, on the other hand, are more interesting because the main goal of unit test is not to catch bugs in our code. Its primary reason for existing is to help us structure our code and prevent bugs from entering the code base in the first place. So having tests to catch bug, you're doing something wrong. This test should guide your design or should help you structure your code. Another, so to say, another great application of unit tests is parameter validation. Because modules often take quite a lot of parameters, testing all of the combinations using integration tests would simply take too long. But unit tests are usually fast. We can execute around a few hundred tests in just a few seconds. So this makes it feasible to check a wider range of combinations of module parameters. And the last thing that tests help us maintain is backward compatibility. To ensure backward compatibility, we need to run our tests as often as possible. For example, in Sensu Go case, we run our tests on every change to main branch. Basically, anything that gets added to collection is always tested against the whole battery of tests. And backwards compatibility, while it may not sound important, it actually really is important. Because when you break the backwards compatibility, you force users to go over some existing content, and this gives them the opportunity to think about other products that would do the same thing, which is probably not something that you want in your customer. But no matter how hard we try, no matter how many tests we are, things will go bad eventually. That's just the law in programming. So this is where the certification program kicks in. Certification program is basically a safety net that says if something goes wrong when you are using playbooks, there will be someone who will help you fix it. So, for example, if you are a Sensu Go collection user and something goes wrong, you can report a bug to us, so the collection developers of Sensu Go, and we'll help you determine where exactly the bug is, and we'll make sure that thing will get solved. So, in other words, no matter how deep this crack goes, there will be someone who will help you fix the bug you just fix your bug that you encountered. Yeah, so basically, this is a short overview of some of the technical aspects that make a difference when you develop Ansible collections. If you want to have high quality Ansible collection, this means that this is a collection that end users will love to use, or they will not be afraid to use. So you can actually follow some of the steps when you develop your own collections, and this will help you improve your collection. So identify usage patterns before you start to code. This is what I said. We actually write a playbook before you add a new module or a new role. Keep interfaces and behavior consistent, and write code and test at the same time so that your code will be structured better. So this is all from the technical perspective. So now I will kindly ask Caleb to tell us something about the benefits of high quality Ansible collections from the product owner's perspective.
That's a great overview, and really hit on a bunch of the reasons why we wanted to engage with a partner like XLAB Steampunk, and to kind of walk through some of that, our worldview, our perspective on the challenges facing our mutual customers today, users of Sensu and users of Ansible and XLAB's own customers, is that we're just dealing with an increasing amount of complexity in IT. And most organizations over the last decade or so have been, even longer, but in the more recent generation, have been moving more towards leveraging automation to help manage that complexity. We're seeing that be less of an individual team effort and more of an organizational cultural shift. So that's where we've seen things like DevOps really take hold, and a lot of organizations are adopting that. Some applying also site reliability engineering sort of practices there, and really making that commitment to automation a cultural change. And when they do that, then inside of an organization like that, your preference for how you go about adopting new technology is you would like to bring that technology into the organization through your automation systems, tools, workflows. And if you're an Ansible user, you want to use Ansible to onboard new technologies. And that helps in a bunch of different ways. It can make it much easier to get started. It can help the customer, start to see some value much sooner. But also for some of the reasons that you described in the technical overview, it makes that experience more reliable. We can ensure, so as a product owner, I want our customers to have the best possible experience. If our customers prefer to use Ansible in order to achieve that, then we can take advantage of that and make sure they have a very reliable onboarding experience. And as a product developer and maintainer of a product, really paying attention to this use case. So really appreciating that a good percentage of our customers want to adopt our technology using automation means we listen both to the customer, but also to our partners on this journey, that being XLAB Steampunk, in collecting feedback that can help us to improve the core product and really make this use case a first-class use case when you're using Sensu. So some of the actual benefits of using the tools together, we are firm believers in this kind of automation first, infrastructure as code sort of initiatives that many Ansible users are on that journey, and that monitoring and observability should be part of that infrastructure as code journey. It's kind of symbiotic relationship where you have automated infrastructure delivery pipeline in place, and with monitoring also being managed by that automation, then it provides this sort of feedback loop where you can go and make changes both to the applications and the management tools. And in that case, you have a very tightly aligned goals. You want to bring 100% of your systems under automation, and for an effective monitoring or observability strategy, you also need to have visibility into 100% of your systems. So the alignment of using the tools together makes a lot of sense for us and for a very good percentage of our customers. And those benefits I already mentioned are quite complementary of using the tools together. So together, you have a simplified getting started process, that day one operation, but then also managing the solution over time is much easier with the Ansible collection, just because, as you mentioned today, the interface is familiar. Yes, it's a different tool maybe than I'm using Ansible also to deploy operating systems and databases and whatnot, but the interfaces for my team, if my team is using Ansible, is all very consistent because my interface is Ansible. And so, kind of conclusion of these thoughts. We really like partnering with Ansible and Steampunk to develop, this high quality experience for Ansible users. For us, the benefit for us as a software vendor is it eliminates barriers to adoption. We've had customers tell us, I went to get started with your product, some other priority came up, I wasn't able to finish. Later, I came back and I didn't realize at first there was an Ansible collection. So I found the Ansible collection. I was able to get up and running very quickly and start to get value from our product. That's what we want. We want them to have that experience. They're able to kind of get that value much sooner. And then the product starts to become stickier sooner. And they then will have a reliable experience. Of course, we want that. In the best case scenario, that even reduces the burden on us to support that customer, makes them have a better time with our product. And so in the long run, the hope is, and we're starting to see some of the effects of this, that offering this high quality Ansible user experience actually, really starts to affect the bottom line for us as a business. So back to you today.
Thank you, Caleb, for your thoughts. So there are just a few things before we can end this. So if I were to say what are the most important things to take away from this presentation is put end user first when designing Ansible collections. End users are the people who will use your content, so you want to make them as comfortable as possible when they author Ansible playbooks. And the second takeaway point taken from the KLab's part is grow your business with high quality Ansible user experience. If you have a high quality Ansible content, users will probably find your product easier to use if they already use Ansible for other things. So last slide from me is, if you are interested in a bit more of a technical details about testing stuff in Ansible Collections, you can join our free webinar on testing. We are having it on 28th of October 2020. And that is it. Thank you for being with us. Thank you for listening, and I hope you learned something, or you know how high quality Ansible collection looks, so you can determine if what you are using today is high quality or not. Thank you and goodbye.